Good morning, good afternoon, good evening, based on the time zone you're joining or watching this video. My name is Victor Monga. I am part of Cloud Security Alliance Los Angeles chapter. On your screen, you can see a QR code that's going to take you to our LinkedIn, Twitter, and YouTube. All of these sessions are recorded and can be found on our YouTube channel. All of these slide decks are available on LinkedIn. So please go ahead and subscribe yourself to those channels and platforms so that you can be notified when we have something new event posted over there, or all of these recordings will be posted. Today, we're gonna talk about week 5, module 5 of our CCSK study group sessions. On the screen, you can see my name, Victor Monga, and Anil Dadani. We are moderators, and we're helping this study group to kind of have this informal group setting where we can discuss these modules and help you guys continue with it. We are also privileged to have Michael Wiley on the call as well. He is our advisor for this study group. So Michael, welcome. Thank you for joining in. Today's speaker is Babu Rao. Babu, I won't brutalize your last name, so do you mind introducing yourself and telling us a little bit about yourself, please?
Sure. It's Gummadela, Gummadela. So my name is Babu Rao Gummadela, so you can call me as Babu. And yeah, I work as a software engineer from past 11 years. So I'm from Microsoft application development background. So far, I was working with the Microsoft technologies, and now recently I moved to the cloud side like Azure and all. And yeah, so I have pretty much interested about the security about on cloud platform. So I was just exploring a couple of things, and I thought this is the right opportunity for me to start with it. And I should be thankful for everyone right now for sharing their knowledges, as well as the CCSK for giving the opportunity.
Awesome, thank you. All right, quick about intro to CCSK study group. So we formed the study group about, I want to say 5 weeks ago. And the 6 weeks training / informal study group setting every week, Friday at 4 p.m. we meet, we talk about the modules. The goal is to just encourage everyone to continue with the training and get certified for CCSK. We are not certified trainers, so you should be accepting or you should be receiving official training either online via our free training program, or we have different means of getting you 20% off until May 31st. So we'll talk about that. There you go. There's a code Train Anywhere. If you use that through May 31st, you'll be able to get 20% discount for online training. As I said, we are not official certified trainers, so you will have to go through the training in order to grasp all the modules and understand the content. The setting of study group is just to get together everyone and talk about these modules so we can bounce off ideas, or if there is anything that you have gone through it, you would like to share with the group. And for those qualified members who got free training from Cloud Security Alliance LA chapter, we encourage you to go through all the modules and go through all the training and make sure you're certifying yourself. This is a huge investment from Cloud Security Alliance, and I know Anil and I have worked day and night, to be honest, to write the justifications, write the program, how we're gonna have the study group meetings and all that, to make sure we can prove to Cloud Security Alliance that their investment and their efforts will be recognized by the community. And in return, all we ask for is your commitment. So please make sure you are certifying and training yourself for CCSK. A little bit about CCSK exam. There are 14 domains, 6 modules, and only 1 exam. So you'll get about 60 questions you need to complete in 90 minutes, which is a lot. Actually, I've taken the exam, I passed it. So that sets the bar. If I can pass it, every one of you can. The passing score is 80%, which is minimum. So you have to pass, in order to pass, you have to get 80% passing score. As I said, this is 6 weeks study group. We've been going through it. We started May 1st, and Today is on May 29th. This is our week 5, module 5. For all the past weeks, we have the material training, recording posted on YouTube and LinkedIn. So feel free to review those as well. What we expect at the end of it, that you will learn CCSK, train yourself, and go for the exam and get certified. During module 1, we talked about resource pools. There are 6 units in it, and all the slides and recording is available. If you actually scan this QR code, it'll take you to our LinkedIn and YouTube channel where you can find these recordings. So I won't go through it one by one, but the idea is we have videos embedded into this slide deck. So when you receive it from today, you can actually go through the previous weeks as well. And there are actually short URLs as well if you want to just get to the link for the week 1. So there's week 1. Week 2, we talked about different software-defined networking and the challenges. I explained about how to do packet captures and management plane packet capture, and how the challenges have brought cloud security as far as goes to, if it's on-prem data centers, you can just do a span port and get all the traffic and analyze it. With cloud, you have to have different means and different methods, and you have to think about all of those things. There were 7 units, and once again, all of these slides are available. You can scan it and review them. Week 2, again, we have video. So again, I'll just pass through it. Module 3, same thing. We have the video, we have the slides available for you guys to review it. Module 4, same thing. We have the slides, we have the recording available for you guys to review it. And the last, we always want to make sure we harp on this point and remind everyone, including myself, that the cloud is all about shared responsibility. You must have heard this term from me or every speaker who speaks about cloud: shared responsibility. Why are we still talking about it? I mean, we got the point, shared responsibility. The reason is people are still making mistakes. Every single day, you'll be surprised, basic hygiene, shared responsibility. Because there is so many gray lines, there's so many abstractions that we still don't understand, or we don't know the right questions to ask from our provider, cloud provider, or cloud provider doesn't have defined those lines for consumers. So there's still some kind of area where they're always gray, but you want to be clear about it. Rule of thumb is whatever security posture you had it on-prem, you want to try to maintain that in the cloud as well. Not more, not less. At least maybe more. Michael would agree to that, more in cloud. But I would say definitely make sure, not less. Whatever you have on-prem, make sure you are maintaining that on-prem as well. I'll pause here. Michael, Anil, anyone from the attendees, if you guys want to give your example or any experience or anything you want to add to shared responsibility model.
I think, oh, go ahead.
Go ahead.
No, go ahead.
I was gonna say, one thing I want to point out, because I feel like the shared responsibility model is overused, but yet it's still not done right. So almost any cloud security talk you'll hear, they start with this, and I always kind of thought, well, we get it, but I don't think we do get it.
Yep.
So I think it also changes. So it's great that you've got it even broken up, because if you look at AWS's shared responsibility model, the nice graphic that they have, it is it's just broken down by where Amazon's responsible and where you're responsible. But I don't think that's enough, because you actually have so many other services. So the shared responsibility of an EC2 instance is going to be a little heavier on the consumer side, on your side, compared to if you're using a service like Lambda, then the responsibility of security is going to be a lot heavier on AWS, as you're managing a lot less. So I think breaking it down of IaaS, PaaS, and SaaS, if you look at the shared responsibility model for Microsoft Azure and Google GCP, they break it down just like this that you have on the screen, but I think it actually should be down by service. I wish a lot of the providers would say, for Lambda, this is the shared responsibility model. For EC2, this is the model. For Lightsail, this is the model, and break it down even further. I think that would help the industry a whole lot more.
You can actually get those details if you go pull if you're a client, you can ask for their SOC report, and the SOC report has the, usually the UEC, the controls are listed out of what the client is responsible for.
Yeah,
Yeah.
if you like reading the
So-
SOC reports.
Yeah, I know. But
Who doesn't?
another way
Come
to
on,
think,
Michael.
but right. But infrastructure is, just think of it. If you're standing up a server in the cloud, then it's all the same things that you do in the data center, other than the hardware. So you own it all. So that's just a different way to think about it.
Yep. Yep. Yeah, and these are the valid points, as consumer, as cloud provider, as the people who are talking about cloud security, these are valid points. Like, we want to have a way to recognize this is not enough. Like, at the same time, if I'm setting up Lambda, should I have a quick pop-up that, hey, this is what the shared responsibilities on the consumer side versus on the cloud provider? Maybe that would be helpful. So once again, this training, CCSK, is for either you're going to work for a cloud provider or you're going to consume cloud. So all of these valid points, keep in mind, maybe you will actually shape the future of shared responsibility and make it easier. So the point is that keep this in mind. We talked about it. We have beaten this dead horse for a while, yet it's not done right, to Michael's point. All right. With that, I'm going to pass it on to Babu for Module 5 review. Babu, all yours.
Yeah, thank you, Victor. Thanks for everyone for your valuable comments so far. And with that, I would like to start discussing on the Module 5 as part of our 6-module course. So Module 5 is all about the concentration, and main focus is on application security and how it affected with the cloud computing here and with respect to the security. And the second one is how the identity and access management for cloud computing will be leveraged over here with respect to all the cloud capabilities. So we are going to focus on the objectives, which would be around the security in the application development, and how application development has been shaped out in the cloud and in the secure environment, and what are all the capabilities it's been leveraged from the cloud applications. So we are going to cover the modules in this chapter on secure software development life cycle, and testing and assessments, and DevOps and immutable, and the rest of identity access management definitions and standards and practices in the cloud with respect to security. So it's all about how the security is after coming into the cloud, into getting affected in the application development in our day-to-day life, and how it is going to affect in the operational of these applications on top of cloud in a secure environment. Then after that, we will see how identity access management has been developed with the cloud secure capabilities. So I'm moving into the secure software development lifecycle, and here are a couple of challenges as well as opportunities which we are going through right now after moving the development into the cloud with these secure models. So hence into the application development, there will be a couple of pros as well as cons, which will be kind of opportunities as well as challenges which we have got in our application development activities on day-to-day life basis. And these are a couple of opportunities, like the advantages which we will get in the cloud, especially in the development. So those are all nothing but like the responsive, couple of points over here explain, like higher base security, responsiveness, isolated environments, independent virtual machines, elasticity, and DevOps unified interface. So I'll explain you a bit about this one, how these will be affecting into our day-to-day life. Like if we are into the cloud, the benefit is like the responsiveness. That means the standing up the VMs are pretty much fast. I've been into application development from past 10 years, and I was working with a couple of on-premises environments. and then I move to the cloud environment, I can see there are a lot of advantages after moving into the cloud. So this responsiveness agility I have seen over there, like earlier, if we wanted to deploy any development application, we need to have a lot of servers, which will be taking a lot of time for the readiness. Then we used to get the servers, then we used to have all the permissions to deploy our applications into the servers. So it's a process, one by one process, and it will take a lot of time. But after moving into the cloud, like Azure, now we are deploying a couple of applications on Azure. There we are getting the virtual machines on the fly basis within a day sometimes. So the availability and the readiness is very fast. That's what I can see, one of the best opportunity over here into the cloud, which we have got as part of the application development, which it made very easy. And it's an isolated environment. So we are working in a tenant environment. So it will be isolated to our organization. So there is no need to worry all about that. The cloud provider is going to take care about it as part of SaaS as well as or PaaS applications. And elasticity is the scalability of these particular machines are pretty much high. That means it with the auto scaling capabilities within our application, so the resources will be allocated on demand basis. That means if the traffic is high, accordingly the resources will be shared, and if the traffic is low, accordingly resources usage will be very low, and the charge and all will be depends on our usage. That's the biggest advantage which I can see over here in the application development and deployment. And the DevOps, we are going to talk a bit more about it. It's the biggest advantage is continuous integration as well as continuous deployment that we are going to talk in the later point of time. And the unified interface. So we will be having our own panel so that we can have all the administration from one particular place. We can manage all our VMs or services, whatever. So on the other side, coming to the challenges, so here are a couple of challenges like limited visibility, increased application scope, changing threat models, and reduced transparency. So I will come from the reduced transparency. So after getting into the cloud, sometimes we may feel like for the logs and the network traffic are highly dependent on cloud providers. Whereas when comparable with on-premises, we used to have all the information which we are looking for. Something goes wrong with respect to application. If any application is down, right away we used to log into the servers. We used to check where it had gone wrong, like whether it is a network problem or whether it is something else. But over here, we will be having the logging mechanism, but it is up to some extent, not what we used to have in on-premises. That is one of the challenge which we have over here, and changing threat models. Hence, it's a cloud-based, so the attackers will come into lots of different ways that we are going to discuss in later slides by moving forward. And increased application scope. So that means so the cloud deployments with respect to the applications right now, they have to take a lot of other measures accordingly to the cloud infra architecture and even the cloud security capabilities, which has been part of cloud consumer responsibilities. So that should be added to this application development scope. And the limited visibility, like I was saying, the logging or networking, if anything goes wrong, right away we can't go ahead and we can get it. So these are all the couple of opportunities or challenges which we have after moving into the software development life cycle of an application which are deployed over the cloud. And here we have kept a couple of application security phases which are not mandatory to have in the same order. It could be here and there adjustable, but these are all the major identified application security phases, which we will be following in our application development process in any of the environments, like in on-premises or in the cloud. So we are going to discuss all these things by moving forward. So these phases includes the secure design and development, which is nothing but the preparing our application code and code reviews, and it will include the pre-deployment testing. And the next application security phase is secure deployment, which will be a bundle of deployment and assessments, which include vulnerability assessments as well as static and dynamic testing. And the last one is operation. So once our application is deployed, from there onwards, it will go into the operational mode. As part of our operations, we will be monitoring all our applications, as well as we will be conducting some sort of assessments to make sure that application will be healthy, operatable. So these are all the couple of application security phases. Here also we will be having in the cloud-based application development. So coming to the secure software development lifecycle frameworks, we will be having a lot of frameworks right now available in the market. And we can see a couple of over here listed. Those are nothing but from Microsoft. So Microsoft is having its own frameworks in the development process. Couple of users who are predominantly into the Microsoft technologies, they may or may not follow these development life cycle. So which will be like training requirement, from the training onwards, requirements, design, implementation, verification and release and response processes will be included into that framework. And apart from Microsoft framework, we will be having NIST, which is nothing but the National Institute of Standard and Technology, which is an federal identified framework. And this is, if it is a federal project, so they can have these they can follow these frameworks. And if it is an international applications, they can follow ISO, International Organization for Standards Framework 27034. So these are all the couple of frameworks which we have in the SSDLC. And we can use any of the framework which fits to our organization, again, which can satisfy our organization goal in the development and operational process. And other than ISO, NIST, as well as Microsoft Security Development Lifecycle, we have OWASP, which is Open Web Application Security Project. So which is also having its variety of application securities frameworks within it. And there are a couple of companies which will publish their own security models also. So these are all the preferred frameworks if we wanted to implement an application which will be secure in the cloud environment. And with that, I'll move the impacts of SSDLC on the cloud. So the impact is more reliance on cloud provider under shared responsibilities model. As we were discussing the point, like a shared responsibilities model. So the advantage, one of the advantage, if we have all the data from the provider, so advantage is we can leverage the existing security models as well as security layers, which we have, which we have in our cloud, which we have got benefited through the cloud provider. We can use the same security layers within our applications, and we can have them to be responsible for all those security models. So that is one of the biggest advantage. That, as per the discussion, that is when we have the proper data on all the services level, so that we will be having more visibility on what and on what extent we can use their security layers. And high variable, large changes to visibility and control, and high variable difference between providers and platforms. And these are all the couple of impacts when we are leveraging the cloud shared models within our application development lifecycle. And yeah, we are going to discuss the DevOps in the later point of time in this model. So we will discuss the DevOps over there. And yeah, so with that, I will move to the next. So this is the secure design and development process, which can be an ideal model which we can use while developing our applications, which starting with the training, define, design, and develop and test. So in the cloud, the application development differs a little bit when we compare with the on-premises, our own environments. So in the cloud model, we should leverage the process as well as the kind of services which we are getting from the provider, as well as the deployment model. We can leverage everything, and we have and as an organization, we have to make sure our users or our developing teams should acquire the same knowledge, so they can use, they can use the same knowledge to deploy the applications after the development into the cloud securely. So in that process, these elements will fall, like training and define. So these will be like the training to our teams so that they can use the platform very well, and leveraging the platform advantages, they can design our application, so which will be very volatile and very secure. And then the developers can do their code review, and they can do their unit testing and static analysis and dynamic analysis. So again, at the testing phase, it differs from our on-premises environment to cloud, because as we have done so far in the on-premises with a different number of tools, we might not be having the same sort of permissions over here at the cloud. Hence, it's a shared model. So we will be having some boundaries, as well as the provider will be having some boundaries. Within that boundaries, we have to make sure our testing will be done. And so coming to the one at the last phase, it's a pure testing, vulnerability assessment and dynamic analysis and functional tests. We are going to discuss a bit more about this testing in the next unit now itself. So this is a couple of the phases of design and development which can be, involved in this particular cloud while we are developing the applications. And yeah, as we were discussing about the threat model in earlier slide, these are all the threats which will be segregated when coming to the cloud application development. And it stands for STRIDE, S-T-R-I-D-E, which will be defining spoofing, tampering, repudiation, information disclosure, denial of service, and elevation of privileges. And these are different types of threat modeling examples, which we will be seeing in our day-to-day life, in day-to-day application development and operation phases. So we will be experiencing a lot of spoofing emails while we are working in our working environments. By example, by getting some emails by acting those emails as a legitimate emails from the organization, which will tempt us to click on it and they will attack on us. So these kind of threats we do have. This is one of the threat spoofing, and likewise rest of all the threat modeling examples we have over here. And we have one more matrix, one more table over here at the bottom. with the security services. That means what are all the remedies or countermeasures if we have to take so that we can deal with these threats while into the secure software development life cycle, which will be helpful for us in our application also, so that application will be well enough secured in the cloud environment. So
I'm just going to pause here, Babu. And attendees, if you have any questions, feel free to interrupt or post in Q&A. We definitely want to make this more interactive. If you have any questions from Babu, since he had been working in that space and has a lot of experience, so feel free to ask any questions. We have Michael, Anil, myself as panelists as well. If not, then Babu, please continue. Thank you.
Yeah, thank you. So, so far what we have seen is we have seen the development life cycle and what are all the opportunities, benefits, as well as challenges, cons, which we have with respect to the cloud environment and the secure development strategy so far. And we have seen what are all the threat models we can deal with it. And we are switching from the development to the testing. So as we were discussing, the testing is having a lot of changes over here. Like when we come to the testing, we will do the testing is a continuous process. It is not stick to any of the phase. Like we have to do the testing in the design phase, or in the release phase, or after releasing, once the site been to the operations, we have to do testing over there. It's a continuous activity. Whenever it requires, we can bring it up and we can make sure the application will be tested enough. So here in the cloud, we will be having some challenges doing the dynamic testing and doing vulnerability tests. So the static tests and unit tests, which are done by the developers on the day-to-day basis, that can be done as usual. But hence we are in the shared responsibility cloud model. So we will not get all the access to run vulnerability tests. So from my experience, we used to have a couple of mobile applications which will be operated in iOS as well as Android and Windows platforms. So we used to have the security tests right before deploying the application into the organizational cloud environment. So we used to deploy the applications over Azure as well as sometimes AWS. The deployment again will be taken from my cloud team. So they used to do the vulnerability testing by using some tools. So we have seen substantial differences when we were few years back when we were developing and deploying things on the on-premises. There they will be having all the access. So organization has a greater control to consume all the things. But after moving to the cloud, they have to stick to certain rules and regulations as per the contracts, and they have to make sure within this contract and responsibilities, they have to use the vulnerability tools to get the vulnerability tests be done. And the static application security testing, it's as usual, we can do it, but as per the cloud model, we have to make it. But coming to the dynamic as well as other testing, so we have to make sure everything is aligned with respect to the contracts as well as secure models. So in SaaS and PaaS, it will be a little challenging over here. Hence, it's a shared secured model. And in IaaS, we will be having permissions. We will be having a greater permissions when compared with SaaS and PaaS. So the challenge will come when we are working at SaaS as well as PaaS application side, when we are testing the applications after development. And the SSDLC testing and assessment at deployment. So So as I was saying, the deployment phase also, we will be having some sort of testing so we used to test it with the operating systems, OS and images sometimes in our development phase, because to make sure whatever the test environment which we have is the same with the production environment in this cloud also. So when we are developing any applications on the cloud development environment, before going to the production environment, coming to the deployment phase, we have to make sure all the testing should be done properly, and it should be pass all the tests. So we will be having some of the tests over here as we were discussing: dynamic analysis, penetration testing, vulnerability scanning testings. And for penetration testing and vulnerability dynamic analysis testing, we should work closely with the provider, with the cloud provider, and adhering all the rules and regulations. We have to make sure our scans will be done. And there are a couple of ways to do these kind of testings. I mean, multiple ways, so that we can get the more accurate result. And so we are we are under adhering rules of cloud. So we will be discussing those methods by moving forward. And we should include this under this testing, I mean, at the deployment testing to the developers as well as the administrators, because most of the attacks will be happened from the developers as well as administrative accounts, because they will be doing the development. So somebody may be hacked their access, and they can go through with their accesses and attack the environment. So for that sake, so here there is a point: include developers and cloud admins within the scope of penetration testing, since they are often weak links. And these are all the three types of vulnerability assessment testings. In the types we can choose while doing the assessment of the application into the cloud environment. One is testing images in the pipeline. That means we can perform the vulnerability tests on the images of our environment, so that the inner images, everything will be secure. So this will be performed predominantly on the images, not on the whole cloud environment. So we will do the testing on the images, then we will keep this one into our environment actively. And the second one is use a host-based agent. That means, so we will go to a preferred vendor, and we will be taking their help to test our environment in such a model that vendor will give the software, and we will keep it in our cloud environment, and they will run their tests and all, and we will be getting all the test results, and that vendor application will share that test results to the third party, that means external environment to us. So as long as the cloud shared model has the external access, we can go with this model, because we can get the results out of that particular cloud environment after running the tests. And the traditional networks, that means the PaaS as well as SaaS applications, so we can go with the traditional network assessment with the permissions. This required the permissions of the cloud provider. So we will in sync with the cloud provider, and we will sit with them, as I was saying, adhering all the rules and regulations. We can target the applications, scoping this particular cloud environment to be tested, and we will agree on that point, and we will be testing that particular environment. This is like the scope base. That means we will have an agreement with the cloud provider by saying what we are going to assess on this particular testing, vulnerability testing, and we will be doing that. And it might happen sometimes we might not be doing on the original production environment because of the contracts, and it's a shared provider model. So the cloud provider may give a separate the parallel instance for us, and we will be doing all the security tests over there. And only one disadvantage is we have to make sure that parallel environment is aligned with that production environment. Otherwise, it is very less effective. So these are all the TE types of assessments we can take an advantage. I mean, we can go with cloud shared model for the vulnerability assessments. There is no particular definition for DevOps, and DevOps is meant for development as well as operations. So the soul of DevOps is the biggest advantage. We can develop as well as we can do the operations. That means the deployment as well as the testing, everything we can go hand to hand automation with the pure automation. So by leveraging this automation, we can improve a lot of security in such a way that so the developers will go as well as they can keep the code, and with the continuous automation, continuous integration pipelines, we can do a continuous deployment. And after the deployment, we can perform the tests, which are automated tests. We can run tests, and from there itself, we can get all the results of the test. So all we need to do is we have to keep everything in place. And whatever the diagram which you are seeing in front of you is the DevOps continuous integration process. So Microsoft has the DevOps tool pretty much implemented, which is a SaaS-based tool, which can be consumed with the URL. And this is what we can do with in this model. I'll let you know how DevOps will work. So that model will be having one version control, which will be keeping the source code and infrastructure templates as well as server container configurations. So all these source code, infrastructure templates, server configurations are nothing but the configuration text files. So we will be keeping the code, we will be keeping all the infrastructure templates. That means how many virtual machines and what are the networks we need, everything we will keep it here. And server containers, that means whatever the servers we need to deploy, like WFEs, web front-end servers and application servers. And we will keep everything over here at version control repositories. And we will be having agents which will build the continuous integration server pipelines. So we will create an agents, and at that particular time, in that agents, we can incorporate a couple of functional test cases, which will be written or which will be available, and which we can include security tests, and we can push everything with a single click by running the agents. So that's what this diagram will tells us. So we can keep everything like earlier with on-premises, we have to define everything in the documents everywhere. If it is not documented, it is a difficult, lot of difficulty we used to face, because we don't know what kind of infrastructure they have built up. But here everything is pretty much kept at one place, version control. We will push it, and we will push it to the test as well as prod through continuous integration. So in this way, what will happen, right? So we will not miss any configurations, we will not miss any source codes. And one beautiful thing over here is we will be having the audits. That means whatever the code which you have kept under the source code, you have to check in, which will take all your comments. And at the end, if you would like to have which version which I have deployed and which what are the modifications, we can easily get all the modifications, and we can go ahead and we can get it all the security test information at any point of time. So this is all about DevOps model. And yes, whatever we are saying, that will come under immutable and infrastructure as a code. So infrastructure as a code is an important point over here, because here in these templates, we are keeping the configurations of infrastructures, what we are using. Let us suppose if it is a cloud environment, we will be having a lot of microservices. we will be having a lot of virtual machines running, and we'll be having a lot of topologies which will be connected. So here in DevOps, we can keep everything in a configuration file so that it will be available for everyone, which will save a lot of time in the development process, as well as by moving forward in the operational process. And the immutable means it is not possible to anyone to go ahead as do the changes in direct production, because everything is continuously pushing through continuous integration CA and CD servers, continuous development integration servers. So they have to go and they have to do the change. That change will kick off over here, and it will do the integration as well as deployment. So that's where it's immutable. Changes should be done at the version control, and everything will be well captured, and everything will be available for the audits at the later point of time. And yeah, this is what we were talking about. The cloud configuration is now within the scope of. So yeah, this is what we were discussing about the secure operations and architecture. And with that, I'll move to the next. Yes. So how cloud impacts application design and architecture. So here it affects a lot, because in the application development, we will be using into the cloud, especially a lot of microservices. Like if you take an Azure cloud, so we will be using a lot of functions, and we will be using a lot of bot services, which are nothing but microservices which are running onto the Azure. So these are all be segregated. Those are not tightly coupled, because these are independent services, and which will be which is auto scaled and available to use pretty much available to our application development. So it affects the cloud environment affects in this way. Like if something goes wrong, these microservices, one of the microservices is compromised. So it doesn't mean all the microservices are compromised, because they are running in the isolated environment will be very secure. And this is how it affects, and it's immutable infrastructure, like what we have seen in the DevOps. So we will be having a different configurations, separate configurations. So which will be defining at one phase, and to push it forward, we have to go through the automations of which will be pretty much secure, which is not happening. Which will be having a lot of transparency. Increased use of microservices. This is what nothing but the segregation of default services, which we have discussed here. And PaaS and serverless. The PaaS and serverless used over here is with respect to the security point of view. So as almost all the cloud providers into the market right now, they do have a powerful secure layers, and they are having, as a cloud consumer, we will be having some sort of a privilege to use the secure layer. So in our application development, if we are able to use those layers security, it will be easy for us to reliance on the cloud provider, because we are using their security layer, so they'll be responsible for it. So likewise, we can take out the burden from our application development. And this is one of the architecture which we have seen as part of the data security. And here at the top, you can see how we have a security architecture diagram over here to send the information to the drop buckets, and from there onwards, it goes to the analysis services, and by kicking off function as a services functions, and it will take the result back and it will put it in the corporate network. What we have done is, apart from corporate network, we kept everything in the cloud provider region, because the security will be taken care by them. So coming down, there is one more architecture which resembles the same. What we can do, right, instead of keeping everything, we can keep only one service like load balancer, two services, load balancer and NoSQL database to the cloud, and make everything rest of the data, web servers, processing servers, and queue service, notification service in our private network. And we can take the advantages of this architecture because our servers will communicate with the services which is coming from cloud provider, nothing but load balancer as well as NoSQL database, which are which are the front doors for the internet. And our environment is not hitting any, will not accepting any users from internet, so that whenever anybody would like to communicate with our architecture, they would like to access any data from our web servers, they have to pass through the load balancer, where load balancer security is taken care by cloud provider. So, likewise, we can take the biggest advantage of cloud provider environment by using their couple of services into our architecture. So this is all about so far which we have discussed about operations as well as the development, application development into the cloud in a secure way. And then we will switch to there are identity access management. So here I have few slides, 3 slides, which will give the definitions of identity. So far, in the common development, I used to have the definitions for identity, persona, and authentication and authorization. But in this module, I get to know what is the basics. The entity is a base for everyone. Sorry, I couldn't able to explain much, but I can tell you few things over here. The entity is the base one, then on top of it, identity. So which will give the unique expression for us. And to validate this identity, the authentication will help us. So which will authenticate our identity. And after authentication, we can go with the multi-factor authentication, which is mandatory thing in the cloud cloud applications to secure our authentication, our accounts. On top of authentication, so next one interesting thing is authorization. So authorization authentication differs into certain, in a level like authentication, we will pass through our identity, and authorization, we will be getting the data which is authorized after authentication into our applications. So with this authentication and authorization, I will move forward for federation. If we are working in an organization, within an organization, within different BUs, business units, if you wanted to navigate from one application to another application right now, so we will be using single sign-on authentication, so SSO, as authorization, SSO. But let us suppose if you are working in a multi-organization project, let us suppose we are working with different vendor companies. If we would like to access a common application, then this federation will come into the picture. The federation is nothing but the cross domain, they will be authenticating our identity. So that is called federation identity over here. So we will be seeing a lot of federation in a lot of Amazon applications as well as Microsoft applications while moving from one side to another side. So yeah, I'll skip this one right now. Yeah, let's talk about standards of cloud belongs to identity access management. So SAML is the standard authentication standard most of the organization will use, and this is used for the authentication. And OAuth is one of the another standard process of authentication. This is more about authorization. OAuth, that means authorization to the applications. So the SAML used to be for the authentication to authenticate into your domain. After authentication into the domain, if somebody of some of your applications are consuming the data from another applications or database, those calls will be done through OAuth, REST calls and all. And then OpenID. OpenID is the another authentication which is on web platform dependent. OAuth as well as OpenID are both web-based authentication mechanisms. And OpenID, we will see the mechanism by moving forward here itself. And that those three are most common used IAM standards. Coming to less common used IAM standards are XML as well as SCIM, whereas SCIM meant to create the identities. That means to create the users and keeping their identities into the system. We will use SCIM, and XCaml, XACML is also like SAML over the OpenID, but it differs and it's less commonly used. And this is a quick diagram how OpenID works. So I'll go through it quickly. Like if anybody is using OpenID authentication, their request will be transferred between the user, relaying party, and identity provider. So from the relaying party, we will try to access our website, and through identity provider, we will be authenticating. So here we can see the process, how the authentication will go. So whenever any person who is having the OpenID authentication enabled, so he will try to, when he try to log into the application, he will send a request to relaying party with the OpenID URL. Then the relaying party will validate with that user as well as the URL, and it will keep the information, and it will communicate with the identity provider from the backend. It will share some crypto information, and then it will send back with the response to the users, which will enable him to direct to the identity provider through the browser. So in that request in the browser, the URI, it will keep some cryptographic cryptographic keys, so that identity provider will consume that cryptographic keys, and it will check with the crypto information which he got from relaying party. He checks, and if it is okay, then he will again back send the request to the user with the cryptographic information. Again, the user will be navigated to the relaying party, then he'll be allowed to the application. So the biggest advantage is over here. Before he logging in, he will be verified thoroughly, as well as in a big, user-based environments. If users are moved out of the organization, it will be easy for them to disable from their login accesses over here by managing at relaying parties and as well as identity providers. So all these things are token based, and all the requests will be flown to browser only, as OpenID is a web browser identity accessment management standard mechanism. And yeah, these are all the different practices when we are dealing with the IAM. So if we have multiple service providers and multiple multiple identity providers, as well as identity providers and service providers. In a bigger organizations, there are these two hub and spoke model as well as free form model can be used, so that they'll get the biggest advantage from IAM concepts. And the important one is MFA, the multi-factor authentication. So it is very important, because if somebody got username password, if it is a admin account, it will be easy for them to navigate into your cloud account, and from the management panel, they can able to access and they can able to change everything. So it will be compromised, and you can lose a lot of information also. They can theft the information. So in the cloud-based applications, MFA is mandatory, so that if anybody attacked on your username password through your browser attacks, still you can able to sustain your cloud environment securely with this MFA. So MFA will be available in multiple options. One is hard token. That means we will be having one RSA token physically in our hand, which will be generating 6 to 8 numbers code. And while logging into the application, we will keep that code, and it will be from the back end, it will be verified whether you are an authenticated user or not, and we will go. And second one is soft token, which most of the users will use in their mobile phones nowadays. And third one is out of band passwords. Out of the band passwords, sorry, I don't have much insights about it right now. And biometrics, using our biometrics also, we can able to log into the cloud along with our user credentials. So these will fall under different MFA types, which will come under IAM practices. And I am moving from RBAC to ABAC, role-based authentication and attribute-based authentication. So role-based and nowadays, most of the people are going towards attribute-based access controls from role-based. That means role-based means if we are a developer, or if we are a manager, or if we are a tester, we will be having certain level of permissions given on the applications. That is on normal life cycle, normal common applications. So coming to the attribute based, that means though after logging in, we will be having some attributes associated with our user profiles, like countries, regions, and time zones. Depending on these attributes, they can manage the authorizations into the applications which you can access. So that in that case, what will happen, we will be having a lot of control at the granular level, and we can secure our applications because we are restricting any of the cloud user with respect to their attributes. So that's what most of the organizations nowadays moving towards attribute-based access from role-based access, especially in the cloud environment. And entitlement matrix, as we were discussing from past couple of modules, the entitlement matrix will help us to understand the level of permissions for the level of users and for different users to be easily understandable, so that it will be easy for us at any point of time to make sure what kind of access we have and what kind of access we are processing. And accordingly, we can adjust our, we can knowledge transfer to other departments also. So it is a best practice from operational point of view to have these kind of entitled matrix in the cloud, because once we started building the applications or building the virtual machines and microservices in the cloud, after some time, maybe after a few years, for sure, we will be slammed up with a lot of services running and a lot of things created. At that time, it will be easy and useful for us to understand how the permissions or access management has been managed.
All right. So for attendees, you know how to get to our recording. You know how to get to our slide deck. But here's a QR code. Make sure you're scanning it for your LinkedIn, Twitter, and YouTube. You can get access to that, this slide deck and recording.